about the biomechanical necessities for safe and effective snowboarding. Come on board! Safety first.
So to start out with this snowboarding lesson, Jordan is going to have her center of mass over the board. Look how she is perfectly balanced and is ready to hit the slopes.
A published article on biomechanical analysis of freestyle snowboarding revealed that as much as 28% of the injuries snowboarders receive each year are related to the ankle joint complex. These injuries are more common when a softer snowboard boot is worn as compared to a stiffer boot. However, the use of a more compliant boot is preferred by most snowboarders. These boots allow for a greater degree of dorsiflexion and inversion, which, when landing jumps and other maneuvers, can lead to injury. It's a little difficult to see in this shot, but as the rider leans onto the toe edge of the board, we can see that the relative joint angle of the ankle is decreasing while the segmental foot angle is increasing in relationship to the ground. As the segmental angle increases, the rider decreases the surface area of the board that comes into contact with the mountain. A greater amount of force is then distributed over a smaller surface area, slowing the rider down so a carving turn can be made. The same concept applies when the rider leans onto his heel edge. The relative ankle joint may remain in a similar position as it would on the toe edge, however, this time the segmental ankle angle will increase. Many forces are acting upon the snowboarder as they glide down the hill. Gravity is pulling the snowboarder down towards Earth's core. The greater the mass of the snowboarder, the greater the force of gravity. This affects the snowboarder's inertia, or their ability to resist change. The greater resistance to change, the harder it will be for the snowboarder to increase or potentially decrease his velocity and acceleration. The design of the snowboard helps the rider to overcome these forces and maximize velocity and acceleration. Different rocker types and board designs minimize surface area and friction forces that act upwards on the system, as well as distributing the down forces over a greater area. The rider can also manipulate his or her distribution forces by leaning up or downhill. By doing this, they can adjust their angle of force application with the ground and the angle of ground reaction force that acts upon them. Centripetal and centrifugal forces come into play when the snowboarder includes turns and rotational movements in the run. In an article on the dynamic motion analysis of snowboard turns, it is reported that torque is created by the lumbar vertebra, the hip, knee, and ankle joints, and is directly proportional to the posture angles of the snowboarder. Skiers experience a lot of the same forces that snowboarders do, but overcome them differently. One advantage is that skiers have two edges they can distribute force over, giving them a greater potential for speed. If you get nothing else from this video, just remember that skiing is a superior winter sport.